All right. So tonight, what I want us to do is the same thing that we've been doing. Dana, just before you got on, I was telling Akil how I felt a little synergy, a little alignment, because we had made these slides already. And then I came across Pam Harris's workshop, which was all about the friendly, aka the happy numbers. And then Akil made the video about the happy numbers. And then I learned about, that and the Nile River and all that stuff. So I felt like we had some synergy happening there. Like it was some alignment. So that made me even more excited about getting together tonight and having the conversation. So just like we normally do, we're going to introduce ourselves, let people know who they're going to be learning from and with tonight. So whoever wants to jump in first, please go ahead and let the people know who you are.
Dana Harris. I am a veteran educator. I am also the Chief Academic Officer of Young Gurus Math Tutoring.
Welcome, welcome, welcome.
Akil Parker, founder of All This Math, and I've been teaching math for 19 years now, and a father of 3.
Awesome. Thank you so much. And I am Renisha Boone. I am a wife, mother of 1, math coach during the day, and runner of Bud and Bear Fruit at night. So without further ado, we're going to go ahead and jump into our slide deck today as we talk about how to tap into your math genius. And I'm feeling real excited about tonight because I feel like we're in alignment. So our warm up, cool down, icebreaker, whatever name you want to call it, tonight is multiplying. So now, obviously, I know all 3 of y'all already know what these are by heart. However, I want us to take this from the standpoint of a student who does not know their multiplication facts by heart and are using something that they do know to help them figure out these products. So I'm going to give you a moment to ponder on that again. I want you to come from the standpoint of a student who does not know these facts and how could they get to the product using something that they do know. And whoever wants to jump in first, feel free.
I'll go with 6 times 7. and the reason why I chose that is because I've read and heard that the 7 facts are some of the most difficult ones to learn or memorize. And someone might be thinking, well, it's 6 times 7. Well, it's also 7 times 6, right? And so if I was working with a student that was struggling with 6 times 7, most likely I would ask them one of 2 questions. I would say, well, do you know what 6 times 5 is? And if they know what 6 times 5 is, then I would tell them they could break apart that 7 into 5 plus 2. And so then now they'll figure out 6 times 5 is 30, and 6 times 2 is 12, and add the 30 and the 12 because they're more friendlier numbers. The other question that I might ask them is if they know, just what's 2 numbers that you can pair together to have a sum of 7. So they might say 1 and 6. They might say 2 and 5. They might say 3 and 4. And then whichever pair of numbers that they say, preferably not 1 and 6, then I would do the same thing just with the 2 numbers that they chose to break apart the 7 into.
Okay. All right. Akil, what you got?
I wish I had thought of that. I wasn't thinking of that.
What'd you think of?
I wasn't sure how much the hypothetical student didn't know, but I was thinking maybe he or she might have knew the 3 timetables. Maybe the 6 was like too big for them. So I was thinking, well, what if they knew 3 times 7?
Okay.
And if they did 3 times 7, and then they could double that. They could get that product and then double that. So then
I like that strategy. Man, I like that because I didn't think of that strategy.
Yeah, that's what they come to mind. Yeah. just to
Okay.
make the number smaller.
Okay. All right. All right.
3 times 7 is a common one that a lot of kids know.
Okay. All right. So we got two strategies so far. So one, we starting with the fact that we know 6 times 5, and then using that to kind of build up to the 6 times 7. And then we know our threes. So then using the fact that we can double to figure out the 6 times 7. Okay. What about 4 by 3 and 9 by 8?
4 times 3. I would most likely tell the student to count by 4s.
Okay. So skip count?
Yeah.
Okay. What about 9 by 8?
Well, my way for this is like, I don't know if it's easier, but I was thinking along the same lines as breaking the 6 times 7 down into 2 separate problems. I thought to break 9 down into 3 times 8, and then get that and then triple that. You know, even if they have to write it out using the multiplication algorithm. So if they know 3 times 8, they get 24, and then they do the 24 times 3. So I guess it's really like, you know, dividing 9 by 3, dividing 9 into 3 equal parts, and then doing 3 times 8, 3 times, and then 3 times that product, or add them.
Okay.
I like that. I got a question.
Mm-hmm.
So we all know the 9s, you got a few different tricks, the finger trick, or you can write down all the digits. As teachers, right? At what point would you all expose them to the trick? Now, Niche, don't chew me out. Niche, I just looked up and saw you giving me the mama look. Hold up.
I didn't.
I forgot. I said a cuss word. Niche don't like tricks. But since we have that conversation a lot, like at what point would you all feel like it would be necessary? Like, is that like the last resort, or is this something that, you know, you expose a child to after you've been working with them for a while and you realize that they're struggling with those 9s?
Good question. Akira, I'm gonna let you tackle that one.
Yeah, I mean, I might go to the tricks, like after I realize that they're having difficulty, you know, memorizing the 9 facts. Or actually, like, you know, maybe the first lesson. Like if I'm tutoring somebody, probably more likely to do the finger trick with the 9 so they can just see it, and because that might make them more comfortable with it, you know, at first if it comes up. But especially if they're having difficulty like just with the memorization, then yeah, I might try something different. I think at that point I'd be like trying to try anything, you know, to see what works.
So confession. I don't know what that is. Like I see kids doing it.
I learned it off Stand and Deliver. Jaime Escalante.
Ooh, he took it back.
Share that with me, because I don't know
man.
it. Like I see the kids doing it, and I'm like, what are y'all doing?
So it's basically one of the ones digit from the 9 facts is on one side of the down finger. So like 9 times 1, it probably looks backwards here, is 1 and 8. So 18. I'm sorry, 9 times 2. So it's the second finger, and then it's 18. 9 times 1 is there's no number on the side of this, so it's just 9, and then 9 times 3, 2 and 7, and so on and so forth.
Yeah.
It's a little.
It also gets into place value. It gets into place value too.
Does it?
Yeah, because you gotta.
This separation separates the place value. This
yes,
finger?
that means it's no longer a trick.
Yeah.
Okay.
Because
we're mingling place value with multiplication facts.
Okay.
I'm trying to get my out of hot water, niece.
Okay, I'm gonna work on that. Share that video with me, Akil. I'm gonna check it out, and I'm gonna see what we got here. Okay, so thank y'all so much. So we got three different problems that we looked at here, 3 different expressions, and we had a couple different ways. So we broke down the 7 into friendlier numbers, or numbers that the student had knowledge of, something that they had already retained. They already know that fact, and we use that to build. Then Akil talked about doubling and tripling. Okay, so this was multiplication. The rest of the expressions that I have in here are addition. So I want us to, again, kind of think about those friendlier numbers, think about students who would not already know how to do this mentally. You see it and you're like, boom, I got it. But we're taking this from the standpoint of a student who does not have that ability. So how would we give them access to this problem? What would you do?
Place value.
Okay.
So I think about tens and ones in here. So with the first add in, you have 3 tens, which is 30, and 7 ones.
Okay.
And with the 13, you have 1 10, which is 10, and 3 ones.
Okay.
And many kids pretty much have a good understanding of the combinations of 10. So we have 30 plus 10 is 40, and then the 7 plus 3 gives us another group of 10. So now we have 50.
Okay. So interestingly enough, my experience with kids, they don't know all of the sums. Like they don't know all of the different add-ins for 10. Like I even have some students who struggle when I ask them, like, what's one number away? What's one unit away? They are still having to like pause and kind of think about, okay, what is 6 minus 1 type thing. So they don't know all of those numbers that add up to 10. They should, because that was a kindergarten first grade objective for North Carolina.
Definitely.
But my middle schoolers, not all of them do.
I'm gonna stay focused because that's a whole nother podcast right now.
No, I mean, spill your tea. What you got?
I find it so one of the things that I've been thinking about lately, right, is that I think a lot of young kids, this generation of kids, many of them don't understand the power of the mind, right? Because they're Wi-Fi babies, and we got these and all of the gadgets and things like that they have access to from an early age. And so I think that that's one of the hindrances that we're facing in education. Many students doesn't understand the power of their brain to be like a bookshelf. Hey, you got this shelf over here, and on the top shelf, I have information about math. On the second shelf, I have information about science, information about sports, information about all these different things. And so organizing their brain and creating space, because many of us, even adults, fill our brain space with mundane things at times. And so that's the gist of what came to mind when I think about that stuff. And I've been kind of dwelling on that thought process for a while now.
Absolutely. Akil, you have something you want to add?
Well, yeah. I mean, I was thinking about another method, but then I was like, they have to have a certain amount of number sense to do this. So, like, to know that, like, you could break the 13 down into 10 plus 3. Then I'm trying to think, like, if I didn't have my number sense, would I know to do that? Because would I be thinking, like, it's almost like a puzzle, like the 3 fits with the 37 to get me to 40. But I'd have to have a certain amount of number sense to know to even do that. So I don't know if that's something that for a student that like kind of doesn't have that level of number sense, then I would go straight. We doing vertical addition, and you just gotta, add the ones and then add the tens, and then maybe after that, we can talk about some patterns, talk about like breaking the numbers apart, like Dana said, like with place value, because I think place value is probably the best in my opinion, especially when we're talking about mental math. Like understanding place value, breaking the numbers down, and because that even like where's that book at? The book I told you I was reading.
Yeah, I got it.
The magician dude, the math magician.
Oh man, he's amazing.
Secrets of Mental Math. I'm reading this and I'm like, whoa. And I'm like, man, he's giving out all the cheat codes for everything. But one thing he said in there, he was like, all you need to know, the prerequisite is just you got to have your multiplication facts memorized. If you, and he said like at least up to 10 times 10, I think, maybe 12 times 12, maybe 10 times 10 or 12 times 12. But it's a lot of rules, you know?
Yeah. So one of the things that I was trying to relay to y'all the other day in the group chat was that Pam, when she was talking about sequential versus, what was the word I used?
Simultaneous?
Simultaneous is whenever they are moving the 3 from the 13 to the 37, it's kind of happening at the same time versus it being in steps. So them being able to look at it once, like you said, they've developed some form of number sense and understanding, oh, boom, I can move that 3 to the 37. That's going to be 40. 40 plus 10 is 50. Kind of like that's all processing all at once instead of them having to kind of like write it down and follow it step by step in order to get it. She said that's what we would want students to get to. So
there's like a rhythm to it.
Yes.
It's all like a flow.
Yes.
Like,
yes.
Yeah.
I just had a thought.
Yeah.
Finish, niece.
Oh no, I was just saying it's that fluency. Go ahead.
I had a thought, right? So when I seen this for the first time, I've seen that strategy many times, and they're heavy with that in elementary school. When I think about that strategy in this moment, that actually is a good segue into when they get to middle school and start solving equations about balancing equations. And I never saw it from that perspective. So like if even though that's a new strategy, you know, that I would put that under new math. Like I think it's cool because I never saw the connection between that and solving equations.
Yeah, for sure. I was working with a client this past week, and she's so used to stacking. She's in the 7th grade. She has some learning disabilities, and we've been kind of working together. And I'm trying to empower her to let her think like your learning disability does not define you. Like just because this is what they say, they don't mean nothing. So I try to challenge her to look at things a little bit different. So I gave her a problem similar to this, and she was like, Miss Boone, I know how to do that. I'm just gonna put it on top of each other. I said, well, I want to challenge you to look at it differently. Is there something that we can do with these numbers? Can we decompose? Can we compose them in a different way to make it easier for us to perform some mental math, right? And she was like, it's just easier for me to stack them. And I think that's what we will run into when we're trying to do strategies like these. If they've already been taught to stack them, they don't want to try nothing else. Like, I'm good. I already know how to do this. I'm good. Like, I don't need to know nothing else. But I think you said what?
That's their comfort zone.
That it is. And I would actually say, I think you should try something else. Because now this is just going to take your skill level up a notch. Where you can just look at these numbers and do this stuff in your head and move things around, and you're not restricted to having to write it down and line this up and see it this way. I feel like you've been elevated a little bit. That's my thoughts.
Yeah, I agree.
I think this strategy, man, this is a dope conversation already. This strategy, it just came to me. This actually, when you have to decompose the numbers and things like that, it actually displays a higher level of number sense. Because it's easy to, if you line up the numbers properly when we stacking them, think about how many kids just say, oh, 7 plus 3 is 10, carry the 1.
Yeah.
You know what I'm saying? Like they just do it because that's just what they've been taught. They know how to follow directions, right? But then once we stop putting in the zeros and things like that, or we start putting in decimals, it's like, it stuff's crooked. You know what I'm saying?
Yeah.
I remember. Go ahead. Go ahead, Akil.
So that 1, when you say carry the 1, that's another thing. Like, because I'm thinking about my own education and like not even knowing what that 1 represented. Like, I ain't know what, but like now I'm like, oh, what is that 1? That 1 is actually a 10.
Right.
So it makes things make a lot more sense. Like even when, I know we're not, talking about this now, but when we're doing the multiplication algorithm, and I'm like, so in my videos, I'm trying to explain, okay, well, why do you indent? Like, why do we do that? That was something I just knew I had to do. I never knew why to do it though, until I started teaching math methods like 5-6 years ago. I'm like, oh, that's why you do it. Because really you're multiplying by, let me see, if it's in the tens, you're multiplying by, like, if there's a 5 in the tens place in the bottom number, it's not really a 5, it's really a 50.
Right.
So you're multiplying a 50 by the number in the ones place in the top number. So that's why it's going to be, and then, because I ain't really realized, like, I would have students that would say, well, my teacher told us to always put a 0 there. So I remember when I was in 3rd grade, my teacher like had us put like a box or just to put a smiley face there, just so we know,
random
don't
stuff.
put a number there. There shouldn't be no number there.
Yeah.
but I never knew the rationale like behind it. Like, why mathematically is that even that? It's just like, well, it's just a rule. It's almost like, like when I was young, my parents be like, don't ask me no questions, just do it. Like, just do as I say. Just do it. Like, why we gotta do that? Because I said so. Like, that's
Right.
it. And that was like, but I didn't understand the concept though a lot of times.
I'm glad you brought that up because I was gonna say I made a post years ago, and I remember asking people like, why do we put the zero there? And a lot of people knew to put the zero there. They didn't know why. The same thing that you're saying right now, which again, like that's mindless mathematics to me. But one thing that it reminded me of, or that just brought back to the forethought for me, was when you're on the treadmill. Have you ever been on the treadmill and watch how your numbers change when you talk about your distance? So it's
Mm-hmm.
usually to like the thousandths place or whatever.
Yeah.
So if
Mm-hmm.
students understand, like once I get to 9, I go up to 10, boom, this hits 0. Now you got 1 over here. And then it start the little clock, the numbers start increasing all over again until you start filling up all of your place value all the way as you're moving to the left. And I don't know if I know I never thought about it until I started teaching math. But if the kids saw that, like actually saw the distance changing like that as they're on the treadmill, maybe it will make more sense to them, like why we're doing what we're doing, why place value is so important, and why the numbers kind of progress, I guess, it build the way they do. I don't know. Just a random nerd thought as I was walking on the treadmill.
Kill's gonna drop the video next. I love it though. I think that's a really cool like nerd moment, right? Because what I'm learning is we knew patterns, right? If I had my way, we would really go all in elementary mathematics on the many different ways that we could just do addition, subtraction, multiplication, and division. Because
Yeah.
from all of that, we can throw in the geometry, the all of the other stuff that are within the standards, whether we talking about a specific state or we talking about Common Core as a whole. Um, I think it would really help the kids because now we can go deeper into place value. We can go deeper into um, so many other things with the mathematics. But these kids are having to be sped along a lot of times that, like, if they don't have a parent or an adult at home giving them supplemental information, teaching them things like the stuff that Akil does his videos about, teaching them the things like Niche, when you do your videos, like, hey, these are the new math strategies. You know what I'm saying? Where what I love about talking about this stuff with you over the years, Nisha, is you have really expanded my mind to be open to the new math strategies. But it's been so cool because in being open-minded towards the new math strategies, I've had those aha moments like Akil just talked about. Like, oh, okay, I see why this works. Now, there's a couple things that I'm like, it's around your elbow to get to your thumb. I'm still trying to figure out where's the connection between these strategies. Like, because I want kids to know the strategies, but eventually go from using the strategy to building their math, their number sense, to being able to do these things like we were just talking about mentally.
Yeah. I think you know how some years ago, I think it was like this rush of people on social media complaining about their kids coming home with homework and the teacher expecting them to do it in a very specific way. And if their
Mm-hmm.
child didn't do it in that specific way, then it would be counted wrong. I
Mm-hmm.
remember my nephew kind of going through that, like him getting bad grades on stuff because the teacher needed it to be done a very specific way. And the reason why I'm bringing that up is because I'm thinking about elementary school being the time where they get to experience all of these different strategies. They get to see and work with all of these different things, and they have time to go really deep and, hopefully maybe derive some things. But if not, getting exposed to it and having time to practice with it, so that when we get to middle school and now we're talking about having conversations and applying things, and then you using a strategy that works best for you, they actually have something to pull from. I think that's the issue or the challenge that we have, is that our standards are so packed. And like you said, the teachers are having to cover so much that we're ended up going an inch deep and a mile wide. And we're
Yeah.
not really we're not really accomplishing a lot. And I
Yeah.
feel like if, like you said, we focus more of our time on kind of the operations, kind of some of the what we would consider the basics, we would hit some of those other domains anyway because there's a natural connection. Like I was looking at the multiplication table that we've been working with forever. As long as I can remember, we've had the multiplication table. Well, we can use that to talk about area too, because you can look at all the different rectangles that are created within the multiplication table. And that's not even the main objective of it. But because it's related, it's there, and that gives us the opportunity to talk about it. But again, I feel like because we're trying to tackle so many things, nothing is really being mastered.
That
Yeah.
same concept goes all the way up to multiplying binomials. So you think about it. If you start out with the multiplication table, and then now eventually we use it in fifth grade, they use that. That's in the textbooks as a strategy for finding area. But then we're using the area model so much. Now you see when they get to high school algebra, they're using the area model to multiply, to use the distributive property.
Right.
You know what I'm saying? And then now we just extend that area model when we're talking about multiplying binomials and factoring. Like I learned some stuff this year that I never seen. There's a strategy now where you can use the area model to go from from, you know, you use it to multiply binomials, but they're using it also to go from factored form to standard form. And I'm like, oh, this is,
I got,
if I didn't love math, I'd be mad as I'm talking. I'm not mad like I used to be, niece.
Yeah.
I used to be, hey, Akil, I used to throw some fits, man.
I'm telling you, and for anybody watching, man, like I always, you know, I want parents to understand this, man. Like, one of the things I suggest is like, you know, think of the most expensive private school in your district or whatever, and try to go to their website and get like summer math packets or just Google because they sometimes they be putting out like a lot of work, you know, because like I found in my you know, some of my tutoring sessions when I tutor the kids from like, you know, the expensive highfalutin private schools. One of the things I like about tutoring them is because they be coming with these different strategies and methods that I never seen before. So it's like I'll be like, oh, okay, like because that method you just talked about, it's a school out here in the suburbs and outside of Philly, where you know they was doing some stuff, and I'm like, okay, how you do that? You know, but I caught myself getting frustrated a little bit at first because I was like, all right, bro, where's your class work? Let me see the practice problem. Let me see, and I was like, I don't got one. Okay, well he didn't give us one. I'm like, so what you mean? You trying to tell me that your teacher did this problem for you, put it on the board, or didn't even give you an example, and like now he wants you to do this for homework? So we got to the bottom of that, and we found an example. But I always appreciate like kind of working with them for that reason because I always get introduced to like, oh, okay, so this is what they doing. Oh, all right.
And they go deeper into the basics too. In elementary private school, any client I've ever worked with that was a private school student, they go the basics over and over and over again, man. That's why a lot of those private school students that stay for a while, like if they stay K-8, man, they come into high school oftentimes and their number sense is solid. Some of them still struggle with the mathematics, but their number sense is solid. So you really just teach them strategies on how to decode the problem, figure out, do we need an expression? Do we need an equation? What do we need? And once they can pull that out, oh, the calculations are they roll with those.
It's another thing too, like working with that same student. What is it called when you're dealing with you're trying to find the function, right? It's like it's in algebra. You're trying to find the function and you have the pattern. They just give you the pattern. But they give you the table. They give you the table with some of the numbers are listed, some of the numbers are missing. And you just got to go through. So I'm looking at it like, all right, what's the algorithm? Let's find the algorithm because I'm trying to find the function. But he's like, no, my teacher wants us to do trial and error, just trial and error. So at first I found myself getting frustrated because I'm like, I don't want to do trial and error. Like I just want to go straight to the algorithm. But it was like a kind of way, I can't really remember it right now. I'd have to check my notes, but it's a way to like just from using trial and error, like, and we had to figure out like, okay, what the pattern was, and from there, then figure out the algebraic expression that would equate to the actual function. But I had to check myself because I felt like I was getting a little like annoyed, like Nah, man, I'm trying to like, what's the what's
He's like,
what's
this
the
is going
algorithm?
nowhere.
Let's go. Let's get the algorithm.
Oh, that
Trial
is
and
so
error is
funny.
wild at times, man.
Yeah.
Yeah, it is. That's surprising though, because I'm thinking about like having to find the rule based on a table of values. Trial and error, was it like multiple choice, or like what were they picking to run the trial with?
I don't exactly remember, but it was
Okay.
just like they just had to kind of just, I don't know, just do random stuff
Hmm.
and just say, oh, what if it was 2x plus 3? And like, let's see, because I see this number is half of this number.
Hmm.
And but then it's like, well, this number, let's see what happens if I double this number and then add 5,
So
or if
they're
I
looking
double
for the
this number.
patterns. Okay.
Yeah, they looking for the patterns,
Okay.
and they
Okay.
had do it like that.
Okay. So we got another one. We got 52 minus 7. What would you do? Again, not coming from your huge math brains. Okay. We're coming from a smaller math brain, still a math brain, but just not as advanced yet. So, how could we enter this problem?
Do I know how to regroup or borrow?
Okay. So,
So
if that's
if
your
I know,
strategy, we can start there. So, are you saying what you want us to do? Stack?
yeah, stack. Yeah, so let's do the algorithm. 52 take away 7.
Okay.
And then I know that because 2 is less than 7, I know I got to borrow from the 5, which is
Okay.
really well, if I'm the student that doesn't have the deep understanding, I'm just like, I got to borrow from the 5, give the 1 to the 2, and the 2 is going to turn into a 12. The 2 is going to turn into a 12.
Okay.
And then I'm doing 12 minus 7. And the 5, because I borrowed from the 1 from the 5 turns into a 4.
Okay.
So then that's going to be 12 take away 7, which is going to be 5. And then 4 take away nothing because of the blank space that represents nothing.
Okay.
So 4 take away 0 is going to be a 4.
Okay. All right. So I'm trying to remember where I saw this, where they said that students naturally want to work from left to right.
Oh, yeah. Yeah.
So,
Yeah.
I feel like Trey Boys in the Hood.
oh gosh. Okay, so what would they do then if they were working from left to right versus right to left?
I don't even know.
I like left to right. I did a video on that. I seen it on somebody on TikTok did that. I was like, yo, you know how sometimes you see stuff on TikTok, you'd be like, all right, whatever. But then sometimes stuff catches you. Like, whoa, run that back. So yeah, the left to right. But I guess you could do this from right to left though if you do that method. Because the whole thing I realized with borrowing all right, let me back up some. So when I'm teaching this method in a math methods course, I always tell my students to be careful. Like, don't tell students that you can't do 2 minus 7.
Right.
Because somehow that comes out. And
Yes.
like young people will hear that and be like, oh, so I can't do 2 minus 7.
Yep.
And then you tell them why, they'll be like, oh, it's because it's going to give you a negative because 2 is less than 7. So then they go through their schooling career until they get to algebra 1 or pre-algebra, and then they get into class, you talking about negative numbers. Like, hold up, somebody lied to me. My teacher told me we can't do that.
Yeah.
But it's the wording, right? So I always tell them to be careful, say using this method, we don't want to end up with a negative. So we don't want our top number to be less than our bottom number using this method. But then if we use another method, like we do another method where we deal with place value and we're like, okay, well, 5 minus nothing is 5 and 2 minus 7 is negative 5. But that 5 is really a 50. And the negative 5, because it's in the ones place, it is a negative 5. And then you just do your subtraction to get your 45.
Yo, I'm gonna tell y'all. It took me like 3 minutes to realize that that's what she did. Cause I be stuck in my old brain sometimes.
That's what it is. Like once you have been trained, programmed to do something one way, when somebody show you something different, you got to sit back and be like, well, hold on now. Like, wait a minute. What is this? But again, we read from left to right. So why is it impossible for me to be able to compute from left to right?
Because if we need to go borrow some sugar from the tens place, they have some. We don't
That's why you
have
say
none, so we gotta go next door and borrow something, so we can make the Kool-Aid at home.
that's
I
that's
think
that's
what's interesting about this method too, though, is it could be I can see it from both sides of the fence, right? So the 12 minus 7, that's where you got the -5 from, right?
well, I did 2 minus 7.
I mean, yeah, I'm sorry, yeah, 2 minus 7, right, to get the -5. What's interesting, like, I would be applauding a kid that understood that early on, because this what, third grade second grade standard, right? So I would be applauding the kid that understood 2 minus 7 is -5. I'm like, oh, he's gonna be great in algebra. She's gonna be great in eighth grade. You know what I'm saying? Um, so I would applaud a kid that understands that. Um, and I think once I had that aha moment, I was like, oh, that is pretty cool. You know what I'm saying? I just be thinking about sometimes the kids that may still be struggling. And that's why, like, it's like I posted the other day, parents have to be that glue to make those puzzle pieces stick. And it doesn't
Yeah.
have to be high level practice. It could
Right.
be like you were saying earlier, kids struggling with pairs of tens. It could be little things like that. Kindergarten, they're supposed to learn how to pair up 5. And in first grade, pair up 10. And then pair up 20. If you can help your child learn how to do those things, we're not talking about multiplication. We're talking about just creating those grooves in their brain to where they know, oh, 2 plus 3 is 5, 1 plus 4 is 5, 5 plus 0 is 5, 7 plus 3 is 10, 6 plus 4 is 10. Now, when they get to pre-algebra and algebra, their number sense is more solidified. Now, some kids are late bloomers, and their number sense starts being more solidified after they do the different, like they're able to derive certain things, number sense wise. But I think that some of the kids that derive things, those are the kids that really have that joy for learning. And I always applaud. Like, I think that's really what it boils down to: teaching our children at home to have a joy for learning. Like, that was something my grandfather beat in our head, not literally, but he made learning really, really cool. You know what I'm saying? And we're talking about the early 80s, right? But it just, when you get a mindset of how knowledge and wisdom is super cool, you don't really care what you're learning half of the time. It's like, I'm learning something. Like, let's go back to getting the kids to understand, like, yo, I'm learning. Oh man, my brain getting bigger.
So I want to ask this. Imagine you had a student who they knew their number bonds, right? So they knew how to get to 5, whether they were adding and through some subtraction as well. And the student looked at this and said, oh, that's going to be a 5 in the ones place. Because initially they were looking at it as 7 minus 2. Now, I think a lot of teachers would say, no, you can't do that, versus taking the time. And I understand that time is a thing that we don't have a lot of most of the time. But instead of taking the time to let the child see that it's not a positive 5, it's actually a negative 5. You get what I'm saying? Like, because I think that a child could come to that conclusion. Because if I know that 7 minus 2 is 5, then I think I could connect the fact that 2 minus 7 would be negative 5. But I might need a little push depending on how old I am. You know what I'm saying? Like, I might need to see a number line, or I might need to understand, something about the way the numbers operate or whatever. But I think I could
Yeah.
come to that conclusion no matter how old I was. What y'all
Yeah.
think about that?
I think it's dope. I think that that will require the teacher to have a deeper level of mathematics. What I've seen is that we still have a lot of teachers who struggle to have multiple methods. Like, the academic language and the educational field language says that kids have multiple entry points. We want to create multiple entry points. But I don't believe that there's enough training in teacher preparation programs to be able to get teachers to be able to catch that. I think that's a very dope point. Somebody like me, I can catch those things and be like, oh yeah, you're right. Because I even had to stop myself from saying you can't do that. I stopped myself from saying certain things to the kids because of what Akil just said. And I got so frustrated years ago because I'm like, yo, we got to stop telling kids you can't do this. And then 2 years later, we tell them, oh, yeah, you actually can.
It
The
expires. Yep.
groove is already in their brain. And it's
Yeah.
hard to help them unlearn and relearn after that.
Yep. Absolutely. So, before we move on, is there another way we could do this?
Would you break it down with the like what you were alluding to with the number bond to
Okay.
get to 50? So we break the 7 down into a 2 and a 5,
Okay.
and then you want to get to the happy number, happy river, ancient Kemet, right? So 52 take away 2 is going to bring you down to 50. But then you still got to bring, like, the number bonds is like, it always seems like it gets messy with subtraction. With addition, it seems like it's more straightforward. To me, it just seems more messy, but I mean, we can still do it though. Like 52 take away the 2 will bring us to 50, and then we still got 5 left over. I think the part that gets messy is like how it's written here. It's like a plus sign. We're doing +5. So you got to have a presence of mind to know that even though there's a plus sign there, it's still a subtraction problem because you're subtracting a positive. But then, I mean, we could go into that. Like, that's the distributive property. The minus sign is really a -1 that's being multiplied by everything in there. I mean, we could have that conversation.
Yeah. I want to show y'all. So remember on this last one, how we added 3 to 1 and subtracted 3 to the other, right? On this one, what we have to do if we was trying to do something similar like that?
I've been trying to figure out in my head the same thing while we've been talking about this, and I hadn't come to it just yet.
I see what you're saying. Add 2 to -7. Add 2 to -7 and subtract 2 from 52.
So you actually supposed to do the same thing. And the reason why is because of the subtraction symbol. Because I tried it before. Like, I tried to do the opposite, but because of the subtraction symbol here, you have to do the exact same thing. So it's almost like you're subtracting. Well, I don't want to say it that way.
But doesn't that make it a double negative though? So would it be 50 plus 9 or 50 minus 9?
It's almost like you're treating this like you're subtracting a positive number.
Okay.
Makes sense.
So then the subtraction stays the same, but I'm changing the value that's within the parentheses. So I can subtract 2 from the 52, and then I'm going to subtract 2 from the 7, not the -7. So now it becomes 50 minus the 5. And now we're back at 45. So then that's gonna require, like you said, like we were just talking about here, that's gonna require the student to understand that adding a negative and subtracting a positive are synonymous, same thing.
Yeah.
So, like you said,
yo, this could really be helpful. Like, if the teachers really had the autonomy, the space to really go deep into this stuff and let the kids practice it, I see how this could really build that bridge towards the pre-algebra concepts. Like, because every problem we done did, we've all discovered a way of how it leads to pre-algebra/algebra, which I think is super cool. I just would love to see, teachers have the opportunity to be able to do this with the kids in the classroom, and or like us being able to train parents to be able to show them these type of strategies, because that's really, these type of things is really what I feel like will close that gap. You know what I'm saying? Because unfortunately, so many kids, by the time they get to third grade, like third grade is sink or swim, because we're talking about now you got a state test. There's still space to catch up if you have some good teachers in between there and you got some good training at home, whether it's from your parents or whether it's from a tutor or something like that. But yeah, like, because it's still, once again, we're doing the same thing to both sides. So we're balancing the equation. And then in high school, that leads up into chemistry, balancing chemical equations.
Yeah.
So it's now all the learning is interconnected.
Yeah. Yeah. And I think that's the important piece, is them seeing the connection, that the math, the concepts are not on islands, like it's all together. And I think for this one, one of the visuals is like imagining a number line, and like you picking up the piece, and all you're doing is like shifting the numbers, and the difference is still the same. So like that common difference between the numbers. So the difference between, what would it be? Let me see, if I were to draw this on the number line and I'm at 52, the distance between 52 and, oh, how did I do this the other day? 45. We know it's 7. So if I shifted it, the distance will still be the same no matter what numbers. As long as I do the same thing to both numbers, the distance between the numbers should stay the same. Does that make sense?
Yeah. Yeah. If you're doing the same thing to each number.
Yeah.
I'm just picking up the distance and like shifting it on the number.
Exactly. Yeah. Yep.
Okay.
Yep.
Okay.
Yeah.
Okay. All right.
Dana, to your point, I'll never forget 10th grade balancing equations. And I'm sitting there, I'm like, all right, I like this. This is just solving systems of equations with elimination method. That's all we do. I'm just trying to, it's a puzzle. I'm just trying to figure out like basically coefficients. I'm putting coefficients on the compounds.
Yeah.
Mm-hmm.
I'm like, yeah, I was like, give me more of these. I need more.
I remember man, when we was doing it in high school, I was loving it. But I took a class in college and I was like, I wasn't ready.
This is what it was. I couldn't figure it out in my brain. The distance between 52 and 7 is the same as the distance between 50 and 5. That's what it was.
Okay.
Oh,
I had to get it out of my brain. Thank you for saying whatever you just said.
That's that trick. Something else I seen. What is it when to avoid borrowing? It's like when somebody said, all right, so when I was younger and somebody would say, they would be arguing, two people would be arguing, and they say it's the same difference. And I'd be like, the same difference? How you gonna have the same difference? That don't even make sense. And then I thought about it mathematically years later. So when you set the problems up where you have to like, it might be a 4-digit number minus a 4-digit number, and you gotta like borrow in every place value. So they're like, yo, just add 1 or add 2 to the top number, to make and then make the bottom number add 2 to the bottom number, or what is it? Subtrahend? No, minuend, subtrahend, right?
Yeah.
And then you just eliminate that. You eliminate the need to even borrow anyway. Because it's all about the difference between the numbers, but the difference is going to be the same as long as you do the same thing like you did here.
Yes.
50 minus 5 is the same thing as 52 minus 7.
And I think I see that example that you're talking about most often when you have like a whole bunch of zeros in your top number, your minuend, and then your bottom number has like 9s or 8s or whatever it is. So then they shift it down to like 3,999, and then they subtract whatever the number is on the bottom. Yeah. After they've shifted it however many spaces they need to shift it. So yeah, we have talked about a lot of different strategies, and the main thing that I wanted to highlight with this one is people think that, I'm going to do the same thing I did here with this addition. I'm going to do the exact same thing if I have a subtraction problem, but we just saw that it's not going to be the same thing, right? We're not going to be adding to one and subtracting to the other, because we're having to separate that operation from the sign of the number. So I wanted to make sure that we highlighted that so that this could be documented as an additional strategy. All right, so 79 plus 11. This one is, I think this one is super accessible. But again, we're coming from the standpoint of a student who their number sense is not number sensing.
I think that 9 is close to 1. I mean, close to 10. And I think that 1 is close. That 11 is close to 10.
Okay.
So I'm gonna go with the balancing act. I'm gonna take that 11 down to the 10, and there we go. And now we have 80 and 10 and 90.
So again, just getting students to the point where they're able to see those relationships. Place value is key. Y'all said that earlier. Like place value is really important. So them understanding that the 9 and that 1, both in the ones place. Now, what can we do to decompose to get them to friendlier or happy numbers?
And really, in my head, I just realized something. In my head, I count up. I be like, well, technically it's not counting up. I say, oh, 70 plus 10 is 80, and then 9 plus 1 is 10, so 90.
So you decomposing with place value.
Yeah.
You're taking your 10s and then your 1s and then you bam.
That just made me realize. So when I do operations from left to right, it's typically mental. Like when I see a problem like this, I'll do it from left to right. It's just mental math though. So I do be working from left to right sometimes.
Okay. Akil, what you got?
Yeah, I'm thinking like 79. I might do the 79 plus the 1 to get 80.
Okay.
And then add the leftover 10.
All right. Bet. All right, we're gonna move on from that one then.
Woo.
No.
Do I do this as a teacher or as the student? That doesn't
Still student. We still student mode. We're still trying to help the student who doesn't have a strong number sense.
Do they know what 100 minus 25 is?
They might.
All right. So I would say 100 minus 25 is 75. And somebody's like, where's the 3? And I'm like, oh, we just gonna add them up at the end.
Okay.
Yeah, that's what I would like. That's what I would hope to do. Unless we want to stack them. It always seems like I always assume like stacking the numbers and doing the algorithm is like the go-to.
Okay.
Yeah, that's
and then we like branch out from there.
Gotcha.
But but let me ask, is that what's happening in elementary schools in 2024? Are they learning that first and foremost? Is that the primary method?
No, not at all. Not at all. They might introduce you to this and you might not get the algorithm to the next year.
So the borrowing and everything. So they don't immediately go into the stack the numbers algorithm and do the borrow from the 10s place, borrow from the 100s place.
No.
I know I know they do a lot of unbundling. So looking at like how your place values are grouped together and how you need to unbundle them or regroup them so that you can solve. But the stacking is more so, like Dana said, your last step. Like after you already understand conceptually how these numbers work together, okay, now we can set it up like this. That's not supposed to be the first step. Yeah. Yeah. So
what would they possibly do like a number bond like with 25, like break 25 down into, or be expected to do a number bond with 25, like break that down into 3 and 22, so that way you can do 103 minus 3 to get 100, and then still had to subtract the leftover 22.
Okay, yeah, I think they could do that. Yeah,
I think niece, can you do me a favor and show that on paper? Because I think that's a cool strategy that will be helpful to parents too.
So we got 103 minus, and you said we got 22 plus 3 over here, right?
Yeah.
So then we got 103 minus 3, and then minus 22.
It's gonna be 100 minus 22.
The only thing my question would be is, if this is a struggling student, how would they get from 100 minus 22 to 78?
I'm thinking another number bond. Number bond them again. And then
Okay.
break the 22 down in the I do 20 and 2.
Okay, let me go back.
Hopefully they would know that 100 minus 20 is 80. So this kind of reminds me of like doing it like this is basically the combined differences method.
Okay.
Yep.
So we just created a series of smaller subtraction problems.
Okay. Okay.
Until we got to 78.
Yeah. So I
And
was
one thing
thinking.
I'm seeing as we go through these is if kids really have time to work on these strategies that people like me think are like, man, we're going around our elbow to get to our thumb. That repeated practice with this type of stuff actually should at some point start building their number sense. You know what I'm saying? Like, I like what you just did right there, Q. Like, because I was like, at first I was like, oh man, they went to another problem where they have to regroup. But you're if you do this over and over, you're still learning how to build number bonds in your head subconsciously and don't even realize it.
Yeah. And there's only but so many numbers. I mean, numbers aren't infinite and go on forever, but there's only so many numbers you're actually going to use in a math class or even like in daily life. You're going to start to repeat the same numbers. You're going to start to repeat in the same relate. And then, okay, so because the numbers basically repeat when you get to the next group of 10, it's going to be similar relationships.
Mm-hmm.
So then that's when the fluency like really starts to kick in. Because
Yeah.
you start to see the patterns and the repetition.
That's a fact.
I've been thinking about like the students who have a good understanding of those number bonds, even if we just first talk about 0 through 10, just how beneficial it would be from every other group of 10 that they work with. Like, because if I know that 8 plus 2 is 10, then I should know that 80 plus 20 is 100. You know what I mean? Like, I'm just applying the same understanding for the smaller numbers to the larger numbers. But the students, like you said, the students are going to need time to grapple with that.
Yeah.
To make sense of it.
I think this also takes us back to the homework conversation. Because they need that practice. They gotta get their reps in.
Gotta get the reps in. Okay. All right. Let's do one more and then we can wrap. Let's see. Let me see what we got. Oh, we didn't even get to them. Okay. We'll do that next time.
I think this live is also a good example to the young people as well as the parents. The parents can convey that message. Like, you know, I didn't learn the importance of study groups until college. You know what I'm saying? I wouldn't have graduated with my math degree had it not been for study groups, right? And shout out to my homegirl, Dr. McNeil out there. She sees this. We're putting our three minds together to see things from multiple perspectives.
Right.
And if kids would start to really get out of their comfort zone and just talk to other kids, you know what I'm saying? I get there's a lot of external factors, but if you start talking to other kids when you're doing work and things like that in the classroom, because that's important to me. I always feel like the kids are going to learn more from each other than they're going to learn from me, but just the importance of putting the brain together with other people. You know what I'm saying? At least you got the human experience versus just depending on Google or just depending on photo math and all these other sites that kids use to cheat. Because they still don't, they can write down the steps, even for the ones that show you all the steps. You wrote down the steps, but you don't understand what the steps are doing. So now when I give you another problem, you're struggling because you just wrote, you knew it was right, but you just wrote what was there versus if we dialogue, it's just like I'm being vulnerable and saying, oh, that method never made sense to me. But then I hear y'all break it down from y'all level of understanding. I'm like, oh, that's dope.
Yeah. I think it was Akil that said maybe during our first video how we have to make the math kind of like appealing so that they want to come to it versus like forcing it on them type thing. Because I really feel like the journey in getting to the answer is so much more powerful than getting the answer. But because so many people are like, did you get the right answer? Did you get the right answer? Did you get the answer? Like there's so much emphasis placed on the correct answer and so little emphasis placed on the journey to it, then that's why there is no value. Like the kids don't value that part. So if all you want is an answer, sis, I'm going to go to photo math. I'm going to let AI do the work and I'm going to write it down and then I'm going to still get my credit. You know what I mean? So figuring out how do we make it appealing to productively struggle. How do we make it appealing to like figure this out? Like get in there and get, you know what I'm saying? Like roll your sleeves up, see what you can figure out. How do we make that appealing to today's kids?
We got it. I think in the classroom, I think that that's something you could do at home more. In the classroom, it becomes a struggle because number one, with timing and pacing. One of the things that I like is you know, everybody, you got so many schools that are one-to-one Chromebooks and things like that, right?
Yeah.
Like sometimes teachers mistake technology use for effective technology use. Like it's and sometimes they don't even do it intentionally. It's I remember when they first started easing in one-to-one. You gotta use the technology, And then now, unfortunately, districts purchase these different programs and they force you to put the kids on the program. It's like, wait. How about we do some of this stuff, pencil and paper and on the board and things like that, or we front load them with one piece of the lesson, whether it's the skill or whether it's the background information. And then once we get to the independent practice, after they've done independent practice on paper, okay, now by the time you get to this program, it can help support you. Because even the programs that show the videos, those videos don't always help the kids. Some kids, because they got so many different methods that they use and stuff like that. You know, so it's like effective use of technology is really important because kids just gonna be like, hey, well, like you said, oh, you just want the right answer? Oh, okay. I got you.
Yeah, there is a huge emphasis on technology use almost to the point of, I don't like using this word, but it's handicapping. Like it's a disadvantage at this point because I remember the internet going out at school and teachers were like frantic. The internet is out. We can't do nothing. Oh my God, I'm not prepared. Like, what you mean, man? Like, there were people that was teaching before the internet. Like, what you saying right now? But the people are not prepared for those type of situations. And again, it's some of it is because the district has this heavy push on use all this stuff that we spent money on. But you know, everything that you spend money on don't necessarily mean it's gonna be the best for the kids. I think we got to kick it back old school. We got to take it back to some pen and paper. If you Akil and Dana, apparently, because y'all like pens, I see.
Oh yeah. Yeah.
Or pencil and paper.
Hey, what's up?
What's up?
I love me a freshly sharpened pencil.
It just looks so cool when you do math in pen.
But you know what? Somebody actually talked about doing math in pen and talking about like the kids seeing the errors and I guess being able to compare it to like new developments that they make or whatever versus erasing it. And now whatever your initial idea is completely gone. They do talk about that. I've read somewhere or listened to a podcast where they talk about that's a good strategy to use in the classroom. So, all right, y'all, with your pen. All right. Okay. So, it's 9:10. I have held you guys hostage for a very, very long time. And I think that we've had really good conversations. I think that we have I think we've gotten a lot on recording that parents can use. And I think the major takeaway for me is the parents actually using these resources and putting them into practice every day at home because the classroom is not going to be the place. It can't be the place where we're expecting the kids to get everything that they need. What do you guys kind of have to add on to that?
I think schools got to be. I think we should move toward like schools being places more for practice. of skills that are already developed in other places.
Mm-hmm.
Yeah, like y'all talk about, you know, the pacing, the scope and sequence and everything, and
Mm-hmm.
there's not enough time. And I think one of the things that when we have that type of conversation, a lot of the message actually gets lost, because then it becomes a thing of, well, if you're a good teacher, then all of your students should be able to become proficient in that amount of time and in that classroom. It's so many factors, and it really doesn't mean you're not a good teacher. It just means that it's a lot going on. And then sometimes you have administrators, sometimes that don't really know that much math themselves, right? And don't understand math pedagogy. So then you tell them, well, look, like, there's some certain prerequisite skills that these students need to have in order for me to teach this effectively that they don't have. And they'll tell you, well, you're making excuses. I'm like, that's not an excuse. That's a explanation. Like,
Right.
yeah. And I would need more time to, get into, deal with those learning gaps, but yeah, it's gotta be a, at home and in school type situation. It's gotta,
Absolutely.
you gotta have both, especially in this day and age, because now it's been so we've been, or I guess the pendulum has swung, and we've been, so many of us, like, not doing as much at home for so long. It's like the chicken's coming home to roost now. So now we seeing the long-term effects of that
Yeah.
as a reality. So now it's got to go back. We got to figure out another way to get, like we're doing what we're doing now, trying to get parents, not just telling parents to get involved, but giving them the tools to be
Yeah.
equipped to be involved. You
Absolutely.
know, because that could be frustrating too. Like, I'm assuming, like, people telling me all the time, if I was a parent and I didn't have strong math skills and my children aren't really doing that well, and I constantly hear people just telling, you got to do more, you got to do more, and I'm like, how? What am I supposed to do? Like I need some guidance.
Yeah.
You know.
Absolutely. What you got, Dana?
Man, first of all, I gotta shout out my bearded brother, like, cause I feel like everything you just said sound like something I would say, but I would be ranting saying it. So I think I always say this, right? All of the technology that we enjoy using, if we don't continue to teach the next generation about learning, how to learn, how to study, and things like that, and the importance of it, of not depending on the technology, then we'll never be able to advance the technology but so far. You
Mm-hmm.
know, I was listening to a good friend of mine who's an engineer, and he knows a lot about machine learning and things like that. As a matter of fact, he was in a session with 19 Keys yesterday. And I've had the opportunity to meet both of them. But one of the things that he was saying was that with AI, one of the things that is absolutely necessary is to have the human experience a part of it. Because when this AI, when you ask it something and it gives you a response, you need to have that human brain to judge the validity of this response and what adjustments can be made, you know what I'm saying, to
Mm-hmm.
that response. So I say that to say, like, we have to understand that our brain is the most powerful tool we are born with. And even for people that may be born with different um ailments and things like that, people that may learn at a pace that's not as fast as some of their peers. At the end of the day, you said it earlier, Niche. It's about the journey. It's
Mm-hmm.
about the process. Like when we accomplish a goal, certain goals that we accomplish, you can't, especially like in business. Like if we work for a Fortune 500 company and the goal is to make $50 million profit this year, whoever's in charge of us, the CEO, he's not going to care about that in 2 months. He's going to say, "Oh, we need to make 60 million, you know what I'm saying, 60 million profit next year." And as soon as those numbers start going back, it's going to be some complaints. So we just have to really, really get back in a society uh, of pushing the importance of learning, just
Mm-hmm.
learning. They learning all day long. we gotta really start pushing for our kids to learn things that's gonna really add value to their life.
Yeah. I gotta say something. You said something about if we don't get the kids in the habit of learning, that the technology it's not gonna go but so far. I want to add on to that and say that if we don't get our kids interested in learning and interested in the journey, they're gonna be dependent on somebody else to take the technology further because they're not going to have the capacity to add to that in any way.
Mm-hmm.
And I'm so glad that you said what you said about AI and needing that human component because a lot of the kids, they are using photo math, they are using all of these different technologies to help get them to the answer. But then they're not even able to, if you don't have a certain level of understanding, you can't even determine whether or not this what they've given you is reasonable. You're completely reliant on this system, this website or whatever. And who would want to live like that? Well, I don't know how to do some of the most basic things on my own. I'm reliant on somebody else or something else to feed it to me.
You give a person
No.
the power to feed you, you also give them the power to starve you.
Shush.
Mm-hmm.
That ain't the life I want. But me and none of our kids. So no. So we got to keep doing what we're doing. Y'all are out there doing amazing things. I'm always grateful anytime that we can get together and have these discussions because I feel like if nothing else, we're gonna get something from it. So we
That's
just gonna
it.
keep doing
Hey.
the work.
Yeah.
And more people are gonna to come in, more and more people are gonna watch, more and more people are gonna be blessed by the content. So we just gonna keep on making it do what it do. So again, I
This is
appreciate y'all so much.
this is PD for me. This is the
Yeah,
best
it
school
Absolutely.
is.
I ever
It
went to.
really is. It really
And look,
is.
we might need to bottle this up and make it PD for somebody else while you playing.
Huh?
Yeah.
Not the Birdman.
Hey.
All right, y'all. We had one person that joined us on Zoom, and she said that this was amazing. She's been texting me on the side, telling me just
Okay.
how much she enjoyed this. Her little girl is she's supposed to age-wise go into the first grade, but she's actually on the second or third grade level. Because she's in a
Okay.
private school, and they really are pushing her forward, really are challenging her. So she is the mother, she is really doing everything that she can to get everything that she needs for her daughter to keep on accelerating her. So thank you for joining us tonight, Juanisha, and thank y'all again for being here with me. And I want to let the people know, whoever's watching out there, to do whatever it is that you need to do to set things up, set your children up for success. The tools and the resources are out there. Akil Parker has a YouTube channel. Dana has a YouTube channel. We all have tons of resources that are available for you out there. So please, please, please don't wait till it's too late. Let's make sure that we are operating in advance. We're being proactive because you absolutely can bud and bear fruit with all this math because your children are young gurus. Until next time, peace.
Peace.
Deuces.